All right, welcome back guys, and we're going to continue our exploration into identifying ions in solution, which is this whole thing about how do we identify ions in the environment. So with New South Wales syllabus, this is what we're looking at, but of course all these concepts are similar throughout the universe, so it doesn't matter where you're from, you can still learn them. So we've been looking at precipitation conductometric titrations in the last video, and all those sort of things are pretty good for cheap, simple, school-based analyses. However, we can become more sophisticated if we use machines to help us become more precise, especially when the concentrations are extremely low. So this is where we're getting into this section here, where we're going to be looking for the concentration of coloured species of metal ions. And we're going to start off with colorimetry, so let's get into it. Okay, well, I guess before we get into colorimetry, we should get our understanding of what we do in this section with this type of technique known as spectroscopy. Now, of course, you will come across this with different ways because we can call it spectroscopy, we can call it spectrophotometry, but basically it just means the same thing. We're using light to give us some type of ability to measure the presence, absence, and of course the amount of a chemical species. So with spectroscopy, in general, it's a collection of different techniques that we can use in an analytical way, and we're using light to give us information about a chemical species. Now, spectroscopy can give us lots of different information. It could tell us about the type of atoms present or the molecules present, and we're going to find that out in later videos where we're going to say we don't know what type of ion is present here. We can find the type of ion or compound in there. We can also talk about the concentration, and that's what we're going to be looking at in just a moment. How much of it do we have in a sample, and then it can also tell us about the internal structure and bonding within a chemical species. So we're going to see in this region here that we can learn more about the chemical structure by using different spectroscopic techniques, and that's more in the next section. So we're going to look at get an understanding to do with colorimetry, because that's the first technique we're going to be looking at. To do that, we need to understand that chemicals absorb energy. And it's all to do with light. Now let's just review some of the basics of light here. We know that we have the electromagnetic spectrum, and we know we have the visible spectrum just here. So we have longer wavelengths, and as they go along, the wavelengths get shorter and the frequency increases. And as this area here is the visible spectrum, and we can break that up into red, orange, yellow, green, blue, indigo, and violet. And so each one of those colors has a specific wavelength and frequency. And so therefore it also has a specific amount of energy. And even though we don't look at it in the chemistry course, but those who also do physics, we can calculate the amount of energy that a wavelength has. And so we know that this formula here can be used to calculate the specific amount of energy for a particular wave. And the thing is with chemistry is when that wave comes in to interact with the chemical, that energy, if it's the right frequency, can cause the chemical to vibrate in certain ways. It can be absorbed, it can make the molecule move, it can make bonds shorter and longer and waggle, and we'll look at all of those specific terms in the upcoming series of videos. But the key idea here is that we're going to be using light, a specific wavelength of light, to interact with the molecule in some way, and that's going to give us some information, whether it be about the structure of the molecule, whether it be about the concentration of the molecule. We're using light to interact with the molecule to give us more information about it. Now with colorimetry, which is the first technique we're going to be looking at, it's all about this idea that, and I'm going to get rid of that permanent one there, I'm going to use my laser instead. We're going to learn about this idea about absorption of light, right? You know yourself that light's coming from these lights here, it's hitting me, it's bouncing off, it's going into the lens there, and you're seeing it. You're seeing black here because all the light that's coming from the light is being absorbed, therefore it's not being reflected to your eye, and it's the absence of light that we see for black. However, if we hold objects up that have colour, the colour they have is due to the wavelengths that get reflected from its surface. And so that's the same with solutions. So if we have a beaker of copper sulfate here, it appears blue. Why? Because all the colors of light that go in, all the wavelengths of light that go into this solution, some of them get absorbed to different degrees and others don't get absorbed, they get reflected. And so if your eye is here, then what are you going to see? You're going to see mostly the blue color of the spectrum come towards your eye, so therefore the color of the solution is blue. You can see that these ones down here are getting absorbed, and so these absorbed wavelengths is what we can use in the technique of colorimetry to work out how much is there. If we have a little bit of it there, a little bit's absorbed. If we had a lot of chemicals there, then a lot of it is absorbed. So we're using this idea that we can use a specific wavelength of light, in this case we can use orange, and this will be absorbed by the solution. Well, if there's a little bit of it, some of the orange light will be absorbed. If there's a lot of it, then a lot more orange light is going to be absorbed, and so we can use that understanding to work out a concentration value. So to finish off this little quick introduction about what what spectrophotometry is, or spectroscopy is, we're going to be looking at 3 techniques according to our syllabus. We're going to be looking at colorimetry, we're going to be looking at atomic absorption spectroscopy, and UV visible spectroscopy, and I've also put spectrophotometry there because these 2 words are interchangeable. So these are the 3 that we're going to focus on for New South Wales students. Of course, if you're from another state or country, we're going to be looking at other ones as well. You just select on those ones that's relevant to your syllabus. So that's it for this video. We're going to get into colorimetry next. I'll see you in that video.